In this topic, we will be implementing melee as a gameplay ability. Notice how in the debug information of the client 1, you can see regenerating health, mana and stamina. This is because we have applied certain initial effects, which includes the heal infinite effect that we implemented in topic 1.3. So, we will be applying such initial effects and granting starting abilities in C++ in this topic. So, let's get started. In the first section, I want to teach you how to grant, implement and activate a gameplay ability in Blueprints. In my base folder's ability system folder, I have created an abilities folder, within which I'm going to store all of the abilities for my game. So go ahead and create such a folder, and within this folder, create a blueprint class, subclassed from the gameplay ability. Let's just call this GA test. So basically, I would like to prepend all of my gameplay abilities with GA. And within this gameplay ability test, notice how you have two overrideable functions, activate ability and onEnd ability. We will go through the other ability properties while we're implementing melee, but you can just read through these tooltip descriptions and understand what each of these properties mean. First, let's set this instancing policy to instance per actor. So basically, this gameplay ability is now instanced as an object for each actor that is granted this ability. So technically, when you activate an ability, the functionality in this event activate ability is being executed. So this method is where you actually write the ability's functionality. So for this gameplay ability test, let's simply print a log message with the message test ability activated, and for a duration of 12 seconds. So in order to activate this ability, we need to grant it to this hero character. So go ahead and implement event begin play and add a call to its parent function so that even our C++ hero class has its begin play executed. So after a delay of maybe 2 seconds, let's grant this gameplay ability test. So let me use the getAbilitySystem component function. So first let me pass this character object pointer, and from the returning ASC object, search for the method giveAbility. So technically this function, as the name suggests, will grant the gameplay ability and return something known as the gameplay ability spec handle. So gameplay abilities are only granted in the server, so this method will not fully execute if it is being called in the client. So let me use a gameplay ability test and hook up this execution pin into this delay node. When this character begins play, after 2 seconds, I will be giving the ability gameplay test. As in the last section, let me use a debug key left mouse button to activate this gameplay ability test. So from the ability system component of this character class, call the try activate ability by class and pass the gameplay ability test. And in my client 1, if I press my left mouse button, notice how the server and the client say test ability activated. And even if I'm pressing my left mouse button over and over again, so technically a gameplay ability executes on the owning client as well as the server, and not on the simulated proxies, that is the other clients in that session. So our ability did not activate again because Gas thinks our ability is still active, meaning we should end the current ability activation to activate it again. That is done by calling this endAbility method. So we must end this ability's activation in order to reactivate this ability. And this can also be done by using the cancelAbility method. So both these methods pretty much do the same thing, only that one will be marked as cancelled, and whenever the ability has been ended or cancelled, this event onEnd ability is executed. So let me instead actually cancel this ability and print for a duration of 12 seconds if this ability was cancelled. So in my level, notice how I'm able to activate test ability more than once. Both the server and client are activating and executing this ability, and also both the server and client are also executing the onEnd ability event. This parameter is true if that ability was cancelled. So this will be pretty much your operation for any ability's functionality. You will write the ability's functionality in this event activate ability, and at a later time, you will have to call this endAbility or cancelAbility. And you can also handle any cleanup kind of functionalities in this event onEnd ability, that is stopping of any animation or any other such operations. In the GAS documentation project, you can learn more about gameplay abilities. The README file states that gameplay abilities should not be implemented for basic movement input, and also some small interactions with UI. But notice how gameplay abilities can be implemented even for something as simple as jumping, using a potion, or even opening a door. This README file also shows a simple flowchart on how gameplay abilities are actually executed, from the try activate ability all the way to its on end ability, where all of the cleanup functionalities take place. So at a later time, we will be exploring something known as ability tasks, and we will not be binding inputs to the ASC in order to activate these gameplay effects. That is, we will not be using any kind of an enumeration for certain input actions. In this topic, we'll be using something known as ability slots and granting abilities to these slots. And now it's time to implement the melee ability. So in the base folder's ability system folder, and in the abilities folder, go ahead and create a new gameplay ability class titled GA Melee. So now that our melee functionality has been implemented in the combat component in the previous topic, all we need to do now is to play that animation montage. That is, when we play the animation montage, the relevant animation notify state is triggered, which consequently activates and deactivates melee, and then the collision events perform this melee. So in the event activate ability of this gameplay ability melee, I'm using a blueprint node known as an ability task. So ability tasks help perform certain functionalities asynchronously, and these are also known as latent actions in Unreal Engine. And this is similar to the play montage node that we had executed in the previous topic, but this ability task has been programmed to perform that remote procedure call to every client machine. Now let's quickly understand how asynchronous programming works. Normally in asynchronous programming, methods are executed sequentially, line after line. The program awaits the execution of a method, and when the program execution returns, only then will it proceed to the next line. Now let's suppose this method A calls the method B. If this method B takes time, only when the program execution returns from method B, perhaps with the return value, which is from where the return keyword name comes from, only then will the program execution move on to the next line. Now let's suppose method B is asynchronous. In such asynchronous programming, this method B can be made to run in the background. So method B runs concurrently and does not block the execution of method A. And any results from method B can be handled via callbacks and event dispatchers, although JavaScript provides an await keyword to complete the execution of an asynchronous function and use any of its return value. So to summarize, in synchronous programming, methods are called one after the other after each one of their completion, and the program waits for each one of their completion, whereas in an asynchronous programming, methods can run concurrently or in the background, without blocking the rest of the program. So this makes asynchronous programming very efficient for certain latent actions, for example in Unreal Engine for playing a particular animation. Note that this should not be confused with parallel programming, where another thread is instantiated in order to parallelly execute alongside other threads. In asynchronous programming, a single thread is used to concurrently execute an asynchronous method. So such ability tasks allow for such latent and asynchronous programming, so you can operate on when an animation has been completed, when it has blended out, when an animation has been interrupted, and when an animation is cancelled. So I wish to end the ability if the animation is complete and blends out, whereas I wish to cancel the ability if the animation has been cancelled or the animation has been interrupted. Make sure to not call this end ability soon after the play montage and wait, because this being an asynchronous function, the ability will simply end soon after playing that animation. So let's look at the different parameters available to us in this play montage and wait ability task. Like the play montage latent action, we have the montage to play parameter. We also have its rate of play and its starting section. We have a few other parameters. We can choose to stop this animation when the ability ends, which means whenever you call this end ability, this asynchronous task will immediately stop this animation montage. So GAS takes care of all these animation functionalities without you having to implement these remote procedure calls or stopping of any animation. So now it's time to activate this ability. So this will not be done in the blueprint hero, and let me remove the debug left mouse button key event. Instead, this will be done in our player controller. So this player controller is being used in my game mode, So in my base player controller class, in its event graph, I'm implementing the debug key left mouse button event, where upon being pressed, for this controlled pawn, I will attempt to get its ability system component and then activate its gameplay ability melee. Notice how I'm not invoking this melee ability until that animation is complete, or until it blends out. So only upon completion and blending out will this ability be made inactive, and then can I re-invoke this ability. But note that GAS does not track any active status. The activation is rather the difference between the number of times activated and the number of times cancelled. I've planned on making an advanced GAS tutorial, and we will be exploring this in that future tutorial. Only if the difference is equal to 0, GAS deems that ability to be inactive. If by mistake you use this end ability soon after calling the play montage and wait asynchronous action, so what's going to happen is the ability activates and soon after it deactivates. And since we are stopping any kind of animation, when the ability ends, no animation will be played. So just for experimenting, let me just disable this checkbox so that the animation doesn't stop. So if I repeatedly invoke melee, his animation keeps stopping whenever the melee ability is being invoked. It is best to have the stop when ability ends parameters set to true. And now in the second part of this section, let us cycle through all of those 4 animation montages. That is, we will be using different melee montages during each melee execution. Although ideally in a real world scenario, you'll just make one single animation montage, and within this default group, you will drag and add other animation sections. Although both the animations are being played, the animations are not really blending properly. So some developers like to use it this way, but I don't think I'll be doing it like that. Rather, I will use an array of montages and supply each one of those montages into this montage to play parameter. So from the Epic Games Paragon assets, in the Greystone player character class, in the event graph, many different animation montages are being played, and that is being cycled through using an attack count integer. And also notice how this attack count integer is being reset back to 0. So we will be doing this kind of approach, where we will be cycling through many different animation montages using an integer. So we will be cycling through many different animation montages from a particular montage array, and that will be indexed using an integer. And note that this ability is instanced for each actor. That means this current montage array property belongs to the avatar actor that owns this ability. So let's populate this montage array contents. So let me move this aside, and let's do a sequence of operations. So technically from this current montage array, I wish to get a particular animation montage at a particular index. Go ahead and create another integer variable known as montage index. By default, this montage index will be 0, so use this montage index to fetch a montage from this array at that index. Now you may already know that array indices begin from 0. If we play the 0th montage, we want to increment this montage index to 1. And if we play the montage at index 1, we need to increment this montage index to 2. Let's increment this integer index, so that will be in the next sequence of operation. Now there's a problem here. This montage index can increment out of the array bounds and go up to 4, 5 or 6 and so on. And that will cause the array out of bounds error. This montage index has exceeded the last element's index of this montage array. So we need to cycle back to 0 after reaching the last element. Let me get this current montage array and call its length function. And that will be set to our current montage array length. So for example, for an array of length 5, our melee indices are 0, 1, 2, 3 and 4. If the array index reaches 4, we need to cycle all the way back to 0 and then start incrementing normally, because if we increment from 4, we will go out of bounds and keep going to 5 or 6 or more. So this can be done using a modulo operator, which is actually the percentage symbol. So if the array index increments to 4, we can do a 4 modulo 4, which actually equals to 0. So this modulo is nothing but the remainder of any division operation. So a 4 divided by 4 yields the remainder 0. Similarly, a 5 modulo 4 will yield the remainder 1. 6 modulo 4 yields the remainder 2. 7 modulo 4 being 3. And finally 8 modulo 4 going all the way back to 0. So technically, when our index reaches this value of 4, it actually resets back to 0, and now our montage index will again cycle along from 0 to 1, 2 and 3. So it's kind of like a revolver, where you have 6 bullets and you go all the way in one direction, and from last, you rotate back to the first. So we may never encounter the case of going to 5 or even 6. But this modulo operation can always be a safety check if for whatever reason your montage array index becomes 12 or 32 or maybe 43. It will always be within these numbers. So now what we need to do is call the montage index variable, use a percentage sign to call the modulo operator. So we're going to use this montage index as the a value, and for the denominator we will be using our current montage array length. And obviously we'll have to reset this montage index with this new modulo operated value. So if you know your DSAs, you would know. So now imagine in your game, for different characters, you could have different montage array lengths. And this array length is always being calculated, which means even if a character picks up a weapon, this montage array length keeps adding to the different montage array lengths of different weapons in your game. So now every time your melee ability is invoked, your montage length is always being calculated and your montage index is always being reset, even with different characters and different weapons. And that montage index is being used to index and get that montage from the montage array. You would also want to store this ability task's return value into a variable. Just drag from this async task object pointer and click on promote to variable. This will create a variable of the type ability task play montage and wait. This has certain helpful functionalities like end task, and you can explicitly end this task whenever you have to. And we will be implementing many other important ability tasks and also making our own in the future topics. So this is our melee functionality. And now in my client 1, I play the first animation, the second, the third, and the fourth. And now after 4, he's playing them all over again. Notice how for this gameplay ability melee class, we had to hardcode values into this current montage array variable. So this is not a good practice in programming. Like if you had to give this ability to any other character, then you need to keep passing data into this gameplay ability melee. And now whenever that character equips a different weapon, or maybe wields it in dual-handed or single-handed mode, then during all those times, you need to keep passing animation data, and you have to manage how to keep passing different kinds of data to this gameplay ability. So that is quite inefficient and is not recommended. So we need to have a data-driven approach where we can query for data whenever it's needed in different places at different times. So I want to dynamically get animation data whenever my melee is being activated. So that's why in my base folder and in the model folder, I have implemented a data table containing animation data. So this data table contains a single row named hero. So this hero row has a property called animation montage container, within which it has a map, it has a gameplay ability class bound to certain values for the animation montage array property. And notice how I have an array of montage elements. So this is a slightly complex implementation of a data table row. So technically, this data table allows me to query by hero's name and for any of its abilities for which I've configured an array of animation montages. So in this section, I wanted to create such a data table. So I have represented that in JavaScript. We will be following this schema where it is actually a map, mapping the key hero name to a value that is another map. And this map inside maps that hero's ability name to a value that is a list. And this list will be nothing but the list of montages. So a resultant animation montage container will look something like this, where it will be a map of the key values containing hero names, mapping ability names of this hero to a list of montages unique to that hero. So we will be following this schema. This data table animations abides by this row structure, animation data. And animation data is nothing but a blueprint structure that I've created in this model folder. So just right click on an empty space and in the blueprint section, select the structure option. So in this new user defined structure, we'll be adding as many properties. And that structure is what is going to be used as a value for the row name. So that structure is nothing but a map of ability class to a list. So now we can change this data structure to map. Now notice how this map's value can only be another single value. That is, even if I choose anim montage, I can't really change the value's data structure from a single anim montage to an array of montages. You cannot really configure a value to be another list or another map. So how do we nest another list within this map? So this will involve creating another structure. Go ahead and create another structure. Now let's rename its property to anim montage array, or rather list of montages for this demonstration. Search for anim montage object pointer. So here we'll be using an array of montages. So now this list of montages can be packaged as a value of this map. So instead of anim montage, search for your newly created structure. You can choose any ability class, and now you can add as many animation montages as you'd like. So I wish to use the Greystone's melee animations just for this example. So I can use primary A, primary B, and primary C. So we have now created a structure for a new data table. And by the way, let me just rename this to test anim and just right click on an empty area and in the miscellaneous section choose data table. For the row name, that will be our test anim. So you can just click on add, and now you can begin adding new rows. You can rename each new row, and now we can go on adding as many unique animations belonging to this hero for their relevant ability. So yeah, this does require two structures, one for an array of montages and the other to map abilities to this array of montages. So now it's time to use this data table to get our anim montage array. So search for this method getDataTableRow. So this method takes in two parameters, a data table and its row name. So if you search for any kind of data table, the none will be replaced and you can see all of the row names within that data table. And this output row is nothing but that row that has been returned, which was part of this data table. So from here you can find this melee ability class. We can now get access to its anim montage array value, and these are the animations unique to this hero for that ability. Now we can operate on this anim montage array. If the row was not found, let's just simply cancel ability. And if the data for this ability has not been found, again let's cancel ability. And we have successfully procured, at this point, the montage array to operate on. If you also implement weapons, you can create another package that maps a weapon to their animations. And now for the client 1 player, the animation data from our data table is being fetched accurately. Let's also confirm in our blueprint code. So I'd like to add a breakpoint to the sequence node. If I attempt to invoke melee, it stops at this breakpoint. So I can step over or into, and step by step. Notice how at this point, if you hover over the current animation montage array, you can notice 4 variables. You can notice 4 elements. So this means our current montage array is indeed getting the accurate value,